Okay, question number 4. So 4A, the airplane with the wingspan sorry. So the airplane has a length of 42 meter. So the length of the airplane tip to tip is 42 meter. It is flying horizontally at a speed of 350 kilometer per hour. So the vertical component of the Earth's magnetic field is 5 times 10 negative 6 Tesla. Okay, so this statement here and here is telling us the direction of velocity and magnetic flux density, magnetic field lah. Okay, so this is B, this is V. Okay, so we have to determine the induced EMF between the wing tips. So this one we are gonna use B L V sine theta. So the theta is the angle between magnetic field and velocity. Okay, so this is the angle. So angle dia berapa? Angle dia 90 degree. Okay, so from here substitute sajalah all the values and you should get 0.02 volt. Okay, so that is an easy 3 marks for you. Okay, yeah. And then question B pula. So this is a coil which has 120 turns with a diameter of 10 centimeter. So that is Kenapa? This is question 4, right? Oh, I have forgot to take screenshot for question C. Lepas ni. Okay, so D is equal to 10 centimeters, so 10 centimeter. And then we have the magnetic field, which is 0.25 Tesla. And then the magnetic flux is decreased to 0. So this is the initial. And we have the final magnetic field, which is 0. Within berapa saat? Within 5 seconds. So we have to calculate the induced EMF in the coil and state the direction of the induced current. Okay, so induced EMF in the coil, we can use the formula negative NA dB over dt. This is the rate of change of magnetic flux. So this one, first we need to calculate the value of no, we don't have to calculate anything. Oh yeah, we need to calculate the area, which is pi r square ataupun pi d square over 4. So this one, the induced EMF, kamu akan dapat 0.047 volt lah. Okay, and then the direction is gonna be clockwise, so you will use the right hand rule lah. Okay, so if we do it, wait let me draw it for you. So sekarang ni kita punya current, kita punya magnetic field is pointing down. So x banyak pula x, astaga, buruk pula. Okay, this is our x. Okay, so now we are gonna use the right hand grip rule to show the direction of induced current. So let me try to draw it. Astaga, dapat ni saya lukis ni. Macam mana ni mau lukis? Kejap pa. So our thumb will be pointing di dalam, because x is telling us that the arrow, that this is going into the page. Okay, this is going into the page. So our thumb will be pointing on to the page, into the page. So kita punya jari akan tunjuk macam ni, kan? So this is gonna be our induced EMF, induced current punya direction. Alamak, harap-harap kamu dapat faham mo. Beginilah induced EMF kita. So induced EMF kita akan go, not induced EMF, induced current. Okay, so our current is, the direction of the current is based on the other 4 fingers lah. Okay, so this is our induced current. This is the direction. Macam mo lukis jo ko kan jari tapi tiap pandai pun actually. Okay, so hopefully you get that. Just do your right hand grip rule. So our thumb will be pointing onto this screen, into the screen, and then our other 4 fingers is showing a clockwise motion. Okay, so clockwise motion ni macam ni lah. Okay, so the direction is clockwise. Alright, that is question B. Now I have to screenshot question C pula. Sorry for the delay, everybody. Okay. Wait Okay, so this is question C pula. So for question C ni kita perlu, this is a solenoid. So an A core solenoid, it has 100 turns of wire per meter of length. Okay, so that is N over L. So that is 1000 turns per meter. Okay, so this is per meter lah. So it has a cross section area of 800 millimeter square. That is 10⁻⁶ meters square. So we have to calculate the self-inductance of the solenoid. Okay, so remember we have a formula exactly for solenoid. So we are going to use that equation, which is mu0 N square A over L. Okay, so sekarang ni given that the length is 500 millimeter. So that is 0.5 meter lah. Okay, so we are going to calculate the new N, which is 1000 darab dengan 0.5 gives us 500 turns. Okay, so just directly substitute all the values. So 500 here, area is here, L is here, and mu0 is given in the list of constant values. So you will get 5.03 times 10⁻⁴ Henry. Okay, so that is Roman 1. Now Roman 2 pula, we have to calculate the average induced EMF. Average induced EMF as the current is decreased from 0.8 to 0.1 in 0.05 seconds. So that is actually the rate of current decreasing lah. Okay, so we are going to use negative L di over dt. Okay, so from here di over dt is the final, which is 0.1 minus the initial current divided by the time it takes to reduce to 0.1. Okay, so L is the one that we use here. So from there you will get 7.04 times 10⁻³ volt. Alright, so that is the solution for question number 4.